Let's take a look at this example. There are many ways to solve this kind of problems. I'm going to use the Thevenin's theorem to solve the following quantities. Now I'm going to make the test first. Okay, I'm going to check if across resistor R2 I'm going to have enough voltage to make these two diodes conducting. Okay, so at the moment I'm going to simply assume that we do not have this part of the circuit. I mean, we do not have this branch. We have simply three resistors in series. And I'm going to find the voltage across resistor R2. I'm going to use the voltage divider formula. So VR2 is equal V1 times resistor R2 over R1 plus R2 plus R3. Okay, this is my voltage divider formula. So VR2 is equal V1 15 volts. Inside of the parentheses I have R2 2 kilo over 1 kilo plus 2 kilo plus 3 kilo. Okay, this is equal. I have 15 times 2 exponent 3 divided by 6 exponent 3. Okay, this is equal 5 volts. Okay, so voltage across this resistor without this branch is going to be 5 volts. So 5 volts is greater than 1.4 volts because the sum of the voltage drops across these two diodes is 1.4 volts. So if the voltage across resistor is higher than potential of these two diodes added together, it means that the diodes are going to conduct and resistance is not extremely big, so you know the diodes are going to conduct for sure. That's why I'm going to write that if VR2 is greater than 2 VD, right, it means that you know we can perform our analysis. If it would be VR2 less than 2 times VD, it means that the current is not going to flow into this branch, but in this case everything is going to work fine. So next, you're supposed to realize that in order to use the Thevenin's theorem, I'm supposed to redraw the circuit. Okay, so what I'm going to do, I'm going to remove the diodes, okay, from the circuit and simply draw something like this. I have voltage source, I have R1, I have R2, and I have R4, and this is my V1, and from this branch I'm going to just leave resistor R3. Okay, so in order to Thevenize the circuit, we're supposed to find VTH. VTH is the voltage across resistor R2, and we found that voltage already. It's over here, 5 volts. So VTH is equal 5 volts. Next, we're supposed to find the RTH. In order to find RTH, we're supposed to simply short the voltage source. So we can redraw the circuit again, and we have R1, this is my R2, and this is my R4, and this is my R3. Next, I'm supposed to find my RTH. In other words, total resistance of this circuit from this side. Okay, so the very first thing which I'm going to do, I'm going to find the resistance R14. I'm going to connect these two resistors in series. They're already connected, but I'm going to make the calculations. So if R14 is equal R1 plus R4, so R1 is equal 1 kilo ohm plus 3 kilo ohms. So if 1 kilo plus 3 kilo is equal 4 kilo ohms. Okay, so now this resistance, all right, the resistance R14 is in parallel with R2. That's why I'm going to find R1, 2, 4. Okay, so resistor R14 is in parallel with resistor R2. Okay, divided by R1 4 plus R2. Okay, if you don't understand what I'm doing, you're supposed to review the section called series parallel circuits, okay, or combinational circuits. So we have R14 is equal 4 kilo ohms times R2, which is equal 2 kilo ohms, over 4 kilo ohms plus 2 kilo ohms. So R1, 2, 4 is equal 4 exponent 3 times 2 exponent 3 divided by 4 exponent 3 plus 2 exponent 3, close parenthesis, equals 1.33 kilo ohms. Okay, so I found the total resistance of these three resistors together. In order to find RTH is the total resistance of this circuit from this side. Okay, so we found the total resistance of these three, so we have to add R3 to this resistor in order to find RTH. So RTH is equal R1, 2, 4 plus R3. This is equal 1.33 kilo ohms plus R3, which is equal 1 kilo ohm, and this is equal 2.33 kilo ohms. Okay, so this is my RTH. Next, I can redraw the circuit. Okay, so I have my VTH and I have my RTH. Okay, RTH, and now I can bring back my diodes. Okay, so this is my D3 and this is my D2. Next, I'm supposed to find the current which will flow through these two diodes. Okay, don't forget that they are silicon diodes. Okay, they are silicons. So in order to find the current, I'm supposed to simply write that my ID3 is equal to ID2, and this is equal VTH minus 2 times VD over RTH. Okay, so voltage, Thevenin's voltage minus voltage drops across these two diodes will give me voltage across this resistor. Voltage across the resistor divided by resistance will give me the current in this series circuit. Okay, the current in the series circuit is the same at every single point. So VTH is equal 5 volts. We found this over here. So 5 volts minus 2 times 0.7 is equal 1.4 volts over RTH. We found 2.33 kilo ohms. 2.33 kilo ohms. So ID3, which is equal to ID2, is equal, I have 5 minus 1.4 equals divided by 2.33 exponent 3 equals 1.54 milliamps. This is the current which will go through the diodes. Please notice that we found the current which will go through the diode D3 and D2. The same current will go to resistor R3. So I can find the voltage across this resistor. Voltage across this resistor is the current ID3, for example, times this resistance. So let's find it. So we have VR3 is equal ID3, it could be also ID2, times resistor R3. So ID3 is equal 1.54 milliamps times R3, 1 kilo ohm. This is equal 1.54 volts. Okay, so this is the voltage across resistor R3. If I have voltage across resistor R3, I can add these voltages together and I'm going to obtain the voltage across resistor R2. So VR2 is equal VD3 plus VR3 plus VD2, which is equal 0.7 volts plus 1.54 volts plus 0.7 volts. This is equal 0.7 plus 1.54 plus 0.7 is equal 2.94 volts. Okay, so this is the voltage across resistor R2. Okay, because this voltage plus this voltage plus this voltage will give me this voltage. The problem is asking me to find IR2, the current which will go through this resistor. So if I have voltage across this resistor and I have resistance, I simply use Ohm's law to find the current. So IR2 is equal VR2 over R2, where VR2 is equal 2.94 volts over R2, which is equal 2 kilo ohms. This is equal 2.94 divided by 2 exponent 3 is equal 1.47 milliamps. So I have 1.47 milliamps. Okay. So I found current IR2. The problem is also asking me to find PR3, the power at this resistor. So we found the current which will go through this resistor. Okay, and we have resistance, so we can find the power. I'm going to write this over here. So if PR3 is equal IR3 squared times resistor R3. This is equal, IR3 is equal to ID3 and ID2, and this is equal 1.54 milliamps raised to the second power times R3, which is equal 1 kilo. So PR3 is equal 1.54 exponent 3 negative raised to the second power times 1 exponent 3. This is equal 2.37 milliwatts, and this is the power at my resistor R3. Next, I'm supposed to find the total current. Okay, total current is going to be nothing else than the sum of these two currents, current IR2 and current ID3. Okay, please keep in mind that ID3 is equal to the IR3, and this is also equal to ID2. So if I'm going to adjust these two currents, I'm going to have I total. So I have I total is equal IR2 plus ID3. So this is equal IR2 we found is equal 1.47 milliamps plus ID3 we found is equal 1.54 milliamps. So I total is equal 1.47 exponent 3 negative plus 1.54 exponent 3 negative is equal 3.01 milliamps. 3.01 milliamps. Okay, so we found everything, and we can say that the problem is solved.